Bus arbitration. The device that is allowed to initiate the data transfer on the bus at any given time is called the bus master. Means now here processor is connected to the bus. Now this is a system bus, processor is connected and DMA is also connected. Here memory is there. So both are connected to the bus, and now here one more device DMA1 and DMA2. If we take it as DMA1, DMA2. Now if both the devices want this bus, now which device is placing the data onto the bus? So which device is having the control of this bus? The device is called the bus master. Now the process by which the next device to become the bus master is selected and bus mastership is transferred to it is called the bus arbitration. Now, if both the devices, now initially, if it is a simple system, so processor is having the control of this bus, and if both the devices are requesting for the bus, then which is going to get the bus master shape, so that a device is called the bus master. That process is called the bus arbitration process. Now here two approaches are there. One is a centralized arbitration. Now in this, a single bus arbiter perform the arbitration. Now what I said, if we take the simple bus, in this bus generally processor is having the control of the bus, so processor will decide which uh, uh, device should get the mastership, that is called the centralized. So here the arbiter is processor will decide the which is going to be the master. Now coming to the distributed arbitration, now all the devices participate in the selection of the next bus master. Now for example, now DMA1, DMA2 both are requesting for the bus master shape, means what, both want the control of the bus, then both will participate in the competition, and which device wins the competition, that device becomes the bus master. This is the distributed arbitration or decentralized arbitration. Okay, now we will analyze the centralized bus arbitration. Now, if you see, this is the diagram. Here, processor is there, and DMA1, DMA2, both the devices are connected. Now, this is the bus request line. Which device need the bus? Those device will send the request signal on this line. Now, if you see here on the top bar is mentioned, means what? It is active low line. So whenever the DMA controllers keeps a 0, then it is activating the bus. If bar is not there, then that time it's supposed to keep the 1 to activate the line. Now here if you see bus busy is what? Bar is there. If bus busy is equal to 0 means what? This bus is under the control of some device. Now initially in the centralized bus arbitration, already we have discussed that bus is under the control of master. But now if we see in few now in a few processor, there is a special device is called the bus controller. Usually this bus controller will take care of the bus, and which devices are requesting for the bus. This bus controller will decide the uh, uh, to give the bus to particular device. Now to understand the concept simply, so simple system, only processor is having the control of the bus. This bus controller is absent. No, but few processor bus controller is also there. Now here we are trying to analyze for the simple system where processor is having the control of the bus. So bus busy is equal to 0 means what? Processor, now at the beginning, processor is having the control of the bus. So now, if the DMA2 wanted to want the bus, then the DMA2 sends a 0 signal on the bus request. So after receiving the, now if this is 0 means what? Processor receives the bus request. Thereby, processor will send the bus grant 1 to the DMA1. Now the DMA1, if the DMA1 already raised the bus request, then it will block the bus grant signal and it will get the control of the bus. Now, if the DMA1 is not raised the bus request, then simply it will propagate or it will cross the bus grant to the second controller by changing the bus grant as a bus grant 1 as a bus grant 2. So now bus grant 2 is reached to the DMA2. Now here DMA2 already raised the bus request. So now it will block the bus grant 2. After blocking the bus grant 2, now the bus busy becomes, it becomes 1. Means what? Now processor release the bus busy signal, it becomes 1. Now it is free. Thereby, by keeping the 0 onto the bus busy, then the DMA controller 2 gets the control on the bus. So now after getting the control, now after placing the 0, again bus request become what? 1. So now if any devices wanted to send the request signal, they can keep the 0 on this line. But at the time bus busy is 0. Now when the again bus is under the control of device 2. If the DMA is using the bus, so no other devices can't place the request signal till the bus is under the control of the processor. So now this is the centralized bus arbitration where the processor is deciding the bus master. Now here the same process we will try to analyze with the timing diagram. Now initially bus busy is also active low signal. If it is 0 means what? It is under the control of the processor. Now at the time the request signal is initially it is high when the any device is sending the sending the low signal onto this request, then the request line will go to the processor, and after that processor sends the grant signal and it will go to the first DMA1. If the DMA1 is raised, then it will hold. If it is not raised, then simply it will propagate to the DMA2 by initializing the DMA1 to the DMA2. Now DMA2 signal will go to the DMA2's grant DMA, sorry, BG2 bus grant 2 signal will go to the DMA2, and after that it is holding the bus grant signal. Then the bus master, then the bus busy line becomes 1. Thereby the DMA2 controller 2 will place the 0 onto the bus busy. So which indicates that now bus is under control of the DMA2. Now at the time, once the DMA2 is getting the bus control, again the bus request line becomes 1. So now till the bus DMA2 completes its job, the bus is under the control of the DMA2. After completing the job, again the bus busy line become 1. Then again the control will go to the processor. This is a centralized arbitration. Now coming to the distributed arbitration. Now for example, device A and device B, both the devices needs the bus control, then both will participate in the competition. Now here A is having the ID of 5, B is having the ID of 6. This is the ID, bus ID, device ID. Now if 5 I can write it as a binary value as a 0101 and 6 I can write it as a 0110. Now this is the bus arbitration lines. So here 4 codes are there. So 4 lines are there. Bus arbitration 0, 1, 2, 3. This is the 0 line. This is a this is a 0 line. This is a 1, 2, and 3. This is the most significant. And along with these 4 lines, start arbitration value line is also there. Now when both the devices need the bus control, when it plays the ID onto this arbitration line and process, it will start, the competition will start by sending the start arbitration value. Now, after placing, now here if you see, A is placing the ID of 0101, nothing but what, 5. Similarly, now here I have shown the only A connection. Similarly, here B connections are also there, and B will place the value of 6, that is nothing but a 0110. Now, in a single line, if two values are placed, then the resultant value of this line is OR, logical OR of the both the values. Now A is placing 5 and B is placing 6 on the same lines. Now here for on 3, A is placing 0, B is placing 6. On 2, A is placing 1 and 1, 0 and 1 and 1 and 0. If two values are available on the single line, then the resultant value becomes what? Logical R. And if you try to recollect the logical R truth table, if A and B, and this is Y, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. If any one of the input value is high, then output is high. So like that, both the values are placed, IDs are placed onto the same arbitrary lines, then the resultant value of the arbitrary line is 0, 1, 1, 1. 0, 0, 1, 0, 0 is 0, 1, 1 is 1, 0, 1, 1, 1, 1, 0, 1. So this is the resultant consolidated ID on the arbitration line. Now these resultant ID will be seen by the both A and B. Now this is the device ID, this is the resultant ID, and both will be compared by the device A and also similarly in the device B. Now in the device A, now device A ID is 5, that is compared with the resultant one. How it is comparing? From the MSB it will check. If both the values are same, it will write the same value. If any difference occurs from that value, it will place the 0. Now in this case, this is the resultant value and this is the original ID. Now 0, 0, both the values are 0, so it will take the 0, and both the values are 1, it will take the 1. Now if you see the next line 1, it is 1 and 0. So 1 and 0 means what? Here the values are differ, so it will take the 0 and it will not check the next value. From this value onwards, it will take the 0 only. Now the A value becomes what? The new A ID is become 4. Now 0, 1, 0, 0 means what? 4. Now similarly, B also compares the original ID with the resultant ID, consolidated ID. Now consolidated ID is what? 0, 1, 1, 1. And what is the BID? Device BID is 0110. Now it will compare from the MSB value onwards. Now 00 means 0, 11 means 1, 11 means 1. Both the values are matching, so it will take the same value. But the last value is not matching, it is differ, so it will place the 0. Okay, now the become when the resultant value become what? 6. Now if you see it, here it is a 4 and here it is a 6. Now the resultant new consolidated value on this line becomes what? 6 only. Now it is, see, now from this and for this, if you take the ORing of these two, resultant value is become 6. Now the resultant value is 6, that is equal to the B, and also the resultant value 6 is greater than the value of A. So now in this competition, B won the B won the competition. So now B gets the mastership. Now this is this distributed or decentralized arbitration scheme. Now in this decentralized arbitration has the advantage of offering higher reliability because operation of the bus is not dependent on any single device. So now here this is a procedure for the distributed arbitration and also a centralized arbitration. Now the distributed arbitration is more reliable. So with this we finish the bus arbitration methods.